Yeah. Is my screen is visible?
Yes.
Okay, cool.
Yes, it's visible.
Yeah. So hi everyone. Yesterday we discussed about, inferential statistics. This is actually part one. Okay. So today we will discuss about the remaining topics what we remind. So let me give you a quick overview of inferential statistics part one, and then we'll start because I just wanted to again to give a overview of the concepts. Just give me a second. This is not okay. Here, inferential statistics is all about, yesterday I told you we are working on samples and population, right? So actually the story all began here. Let me show you. Okay. So we are using statistics to estimate, to come up with an estimated values, right? For example, what is the average score of grade 1 class? Okay. What is the average score of the students in grade 1? What is the average score of the grade 2 students? So we will use some estimated values. That estimated values will help the organizations to come up with to a conclusion. Okay. If the average of the students from grade 1 is less than average of the grade 2, that means definitely the management will definitely question the lecturers or teachers. So why the grade 1 average is very less, grade 2 average is very good? What is the reason? So based on the average they actually conclude, though in grade 1 maybe 5 students score very good marks, toppers of the entire university, but still when it comes to the average, it still scores less. Correct? So average actually is an estimated point. But when it comes to the reality, okay, we will have the two concepts, population and sample. So what is meant by population? For example, if I wanted to know the complete India's average height of a man, okay, average height of the man in India. In India means there are around 140 crores plus population is there. It is very difficult to go and ask everyone's height and then come to a conclusion. Instead, I can collect a sample out of it, and then I can calculate the average and whatever the statistics I want, I can calculate on this sample, and then I can estimate it to the population. Okay. So these estimated values should be so close as population ones. Then only it really making sense. Otherwise, it is really not making any sense. For example, in India, there are around 29 states are there, right? 29 states are there. Each, if I miss, if I take only one state, one particular state, and if I collect only 100 per people out of one state, and I then calculate the mean, so it will be again that mean may not be equal to the entire India's average height. Correct? So sample should be also collect randomly. Okay, it should not stick to one part of the data set. It should collect randomly and cover every data point. Okay, randomly if I collect some thousand out of all 29 states, then some data set I will get. That data set I will calculate mean, and then the population data set also I will calculate, and then I will estimate these two, whether these two are equal or not. If they are so close, then our statistical part is very good. Okay, and in order to do that, we are having hypothesis testing. Hypothesis testing is always something like we will estimate with the reality, with the to the population and sample. For example, the population mean, let us say population mean is x1, sample mean is x1, population mean is p1. Okay, population mean is p1, sample mean is x1. If I wanted to conclude, okay, population mean and sample mean are both are equal, okay, then I have to verify whether these two are really equal or not. Okay, so whatever the statement that you are mentioning, that is what null hypothesis. Yesterday we discussed about this. Null hypothesis is nothing but we are going to define a probabilitical statement. Okay, so two probabilities are same, that is what null hypothesis. Alternate hypothesis is something like this is alternating to this. If this is not true, then alternate hypothesis is true. If this is itself is true, then null hypothesis is true. Alternate hypothesis we need not to consider. Got it? Null hypothesis is defined as H naught. Alternate hypothesis is defined as H1. Okay. So in order to do these things, we are having some G test, okay, P test, P value. These are the important concepts. Yesterday we discussed about this thing. Z test is simply when we have more than 30 samples. T test is used when we have less than 30 samples. If our sample is size is having 30 less than 30, then go for T test. And if we have greater than 30 samples, then we can go for Z test, 30 and more than 30. Okay, then Z test. Ultimately, we will calculate out of these two, we will calculate P value, which is 0.05. Why this is 0.05? Because confidence interval is another concept is there. Usually usually the statistical people always consider 95 percentage of the spread is good data. If we focus 95 percentage of the results, 5% obviously will be there for outliers, right? In every data set, if you consider 95 percentage is what very important. For example, in a class of 30 students, do you agree that all students score above 80? Definitely not. In general, definitely not. Some people score above 60, some people score above 40, some people score above 80, some people, very, very few people will score above 90. That people comes always under 5 percentage of the data set, right? 95 percentage of the data set may be less than 80 only, and 5 percentage of the data, like 5% of the students are maybe after 80. So 95 percentage is what very important. There we have to find all the things. That is what confidence interval. This confidence interval will be determined by the domain experts. Okay, so they will define this 95 percentage is what very important. Okay, and then after that, 95 percentage means remaining is 5 percentage, right? 5 percentage is simply, if you calculate percentages, 5 means 0.05. So usually p value is 0.05. Okay, so if you are getting either z value or t value, if it is less than 0.05, then you are going to reject the null hypothesis and accept the alternate hypothesis. Okay, if your value is greater than or equal to 0.05, then we can say like null hypothesis is what very important. Okay, so simple. Yesterday we defined here some things with the help of data set. The best example here I have given here. uh, Normal distribution also we discussed. This is confidence interval. This is how the confidence interval is look like. So it will help us to determine the upper limit and lower limit. Yesterday I told you. And then here you can see G critical we are finding out, and then margin of error also we calculated. Yeah, hypothesis testing here, P value is very important. Yes, I have given very clear information here. If you refer this, you will definitely get the things. Okay. Anyway, I'm now again I am recapping. So whoever missed yesterday's class, this will help you. Okay, to get the basic things. Alpha is what level of significance, or else we also called as p value. Is always people say that it is better to consider 0.05. If we are getting lesser than 0.05, that means we are rejecting our null hypothesis and accepting the alternate hypothesis. For example, here hypothesis is in neighborhood, there is one column called neighborhood. In that neighborhood, we will have many values like old town. Here I have given you what are the values that are there in neighborhood. Okay, so old town, some values are there, different values. Here you can see old town is there, and Edwards is there, Somerset is there, Gilbert is there. These are all neighborhood names. Okay, here the problem statement is, understand, whoever missed the yesterday's class, or else like if you really want to quick understanding about statistical inference, our goal is here, are house prices in old town really different from the house prices of other neighborhoods? That means we wanted to test really different means indirectly it is saying usually it is same, right? It is same price of old town, house price in old town, and same price of house price of in other neighborhood like Somerset or other. It is question is itself is stating us these two prices, okay, are equal. That is what null hypothesis. Whatever the question is mentioning, that is what null hypothesis. We have to prove whether this null hypothesis is true or else alternate hypothesis is true. Alternate hypothesis is simply opposite of null hypothesis is what alternate hypothesis. If null hypothesis is testing whether house prices in old town and house prices in neighborhood, another neighborhood is same, that is what null hypothesis. If different means, that is what alternate hypothesis. We have to test which one is correct. Okay, because we are going to estimate the samples with the population. Okay, here initially I just took the condition where null neighborhood equal to old town, and then also took the sale prices, the prices of the old town sales price. Okay, house price of only old town, and then I calculated the, I am checking with the overall mean of remaining things. Okay, then this is the formula of z-test in Python. In Python, if you pass the data condition and then the value, you will get directly g-test and p-value. Here the g-test is -10. Here it is what important. P-value is what really important. If you see the p-value is 0.00000 so far, that means it is less than 0.05. That means null hypothesis is false, alternate hypothesis is true. What is null hypothesis? Both are same. This is what null hypothesis is saying. But actually they are not. Old town sale price is different. Other neighborhood sale price is different. This is what we got. Got it? Similarly, if the number of samples are less than 30, then instead of z test, we have to go for t test. Same condition. You can see condition is same. Now we are checking with stone bridge. Okay, BR. Now the condition is, let us also see if the house prices in Stonebrook are different from the houses in the rest of the neighborhood. Now we are checking with earlier we checked with Old Town with others. Now we are checking with Stonebrook with others. Okay. If they are same, then it is null hypothesis. If they are not same, that is alternate hypothesis. How to test? First of all, define a condition and then pass that condition in t-test, and then also mention the overall mean, which particular parameter that is really important, population mean, and then you can see the p-value is 6.55 into 10 power. This is also important. 10 power minus 6. 10 power minus 6 means, you know, right? 0.00000006. This is also less than 0.05. Then we reject the null hypothesis and accept the alternate hypothesis. This is what. And type 1, type 2 errors also we discussed. Chi-square test is also we discussed. Chi-square test is nothing but goodness of fit. Okay, with the help of small data set we used. So this is the formulation. The same thing we implemented here, and then we got the values also. Here you can see chi-square test p-value is also less than 0.05. Okay, that means we can reject the null hypothesis. All these things we discussed yesterday. Go through. Now we discuss the remaining point. Let us discuss the remaining topics, like two sample mean test. This is called t-test. Two sample mean test is also called as t-test. T-test. Okay. Earlier was, that is t statistic. This is t-test. Don't confuse. Z-test statistic and z-test. This is t-test. And remaining concepts are nothing but two sample mean test and the two sample proportion test, and then followed by A by B testing, and then one problem statement, and then ANOVA. With these concepts, we will conclude the today inferential statistics, followed by, after inferential statistics, I will provide you the case studies, different case studies. Yesterday, I already told you how to get the case studies. Anyway, today again I will provide you according to your domain. Okay, you can answer to my questions afterwards on case studies. Okay, first we discuss about let us discuss about two sample mean test. Two sample mean test, why it is important, why it is needed. Here I provided the small description. A two sample mean test is used to compare means of two independent groups to determine if there is a statistically significant. For example, you may face a, see, real world example also I provided. You can also see this. Real world example here I consider a company wanted to compare the effectiveness of two different training programs by measuring the employee performance scores before and after training. That means you are going to compare, okay, two different things. Okay, you are going to compare whenever there is a comparison comes. okay, comparison comes, then you can determine whether it is, you always have to observe whether it is t-test or two sample proportion test. There is a small difference between these two. Anyway, those differences also given near clearly so that it will really helpful to understand the concept to you. Here you can see two sample mean test is always used to compare means, especially of two individual groups. Here, I wanted to calculate the employee performance, the mean of employee performance before training and the mean of employee performance of after training. So before training, let us say their performance mean is out of 100 questions, they are able to answer 40 questions. That means for 40 percentage is what mean. 40 is what mean. Let us consider 40 is what mean. Okay, average they are able to answer 40 out of 100 questions. After training, the mean should increase, right? Because that is why we are giving training to them. So after let us consider after training their performance will be 60. 60, okay, so increased from 40 to 60. So this type of things, whenever you want to compare the effectiveness or whenever you want to compare the means of two independent groups, then immediately this concept be has to remember. Okay, this concept have to remember. Okay, two sample mean test. Okay, what is the formula to do this? So two sample mean test is nothing but x1 bar minus x2 bar. That means two different sample means. X1 means x1 means sample mean of 1, x2 means sample mean of 2. S1, S2 are nothing but so variances. Okay, sample variances. Okay, and then N1 and N2 are sample sizes. Using these things, you can simply put all this in formula. You will get the two sample t-test. So using Python, how to do? In stats, actually in stats, there is one function called t-test ind underscore independent. Ind means independent. Group 1 and group 2, simple. You can pass the group 1 and group 2. By default, it will calculate the mean of group 1, mean of group 2, say variance of group 1, variance of group 2. Number anyway can come by n, right? Length of group 1 is nothing but a number, right? So you by default in behind of this pro function, that is, this is the formula implementation, and you will get the t statistic value and then the p value. Okay, these two things you will directly get using this particular function. Let us go to the next concept called two sample proportion test. It helps. Here you can see compare the proportions. Whenever you want to compare the proportions, instead of compare the means of two individual entire group, instead of group, if we want to compare two proportions, then we have to go for two sample proportion test. Okay, for that purpose we use z test for proportions. Okay, so p cap, p1 cap minus p2 cap divided by, this is the formulation. And here we can see pooled proportion is what we use. Pooled proportion is simply like x1 plus x2 divided by n1 plus n2. These are all core mathematics. Okay, the proofs also available in the internet. If you are interested to go through, you can also go through the theorem and proof why we are getting this formula out of this z test and all. But the overall you can remember the formula. And anyway, in implementation you can directly use the straight away function. In stat models we are having a proportion. Inside proportion we have proportions z test. First of all, we have to pass the success. We have to pass the success. Okay, here we can see I'm just passing the success. It is nothing but array of two values, and sample sizes is nothing but array of two values. Now it is a proportion, right? Proportion of a group, right? That's why these are proportions, and then I'm just passing this proportion z test, success and sample sizes. Then I'm getting again z test, z statistic, and then p value. You might have understand that here also I calculate t test and p value. Here also I'm getting p value. What is this p value really help us? Okay, here I provided you the simple explanation. Why do we require, where is that slide? Yeah, here. Why do we calculate z test statistic or t test statistics and p value? Why do we calculate p value? Because the z test statistic or t statistics, statistic means nothing but we are comparing the proportions. T statistic means we are comparing means of groups. Okay, remember that thing. So why do we require to calculate these two things? Is simply it will tell us how far our sample difference is from the null hypothesis. Okay, if the value of the either z statistic or t statistics is large, it means the difference between the groups is significant. If the value is small, then it determines thus the difference is likely due to the random variation. If it is small, then difference is likely. Okay. And what about this p-value? Why do we require to calculate p-value? If p-value is less than 0.05, we already know about this. We can reject that null hypothesis. Whatever the statement that we are determining, we can reject that. P-value is greater than or equal to 0.05, then we fail to reject the null hypothesis. That means no significant difference is required. Okay, that means we fail to reject means we have to accept the null hypothesis. It may be a confusion thing. Fail to reject the null hypothesis is nothing but we are failing. That means we are accepting. Correct? So you can understand that. Okay. And these two are like that. And so here you can see the two sample proportionality. What is the real world example is if an online store is there that wants to compare the conversion rates, okay, of two different websites designs to see which one leads to more purchases. If they have two different things and they wanted to know which one is more leading, so they wanted to know the proportion, and here whenever the proportion is there, then you can go always z statistic. Then a by b testing. Okay, so a by b testing is also a statistical method to compare two versions a by b. Means a is one version, second is b, either of a product or a web page or a feature. If you have two different things, you want to compare the two different things, then we can go for a by b testing. Why it is important means it helps in decision making for product design. Okay, it helps in decision making and marketing and user experience. It is widely used in tech companies like Google, Amazon, Netflix. Just wanted to determine which one is really good. Okay, compare two versions. Okay, A or B, either two products or two web pages or two features, which is really good. Then we can use A by B testing. How to do this A by B testing? Simply, let us consider conversion. If there is a use case where conversions are there, of conversion of A is there, conversion of B is there. Okay, so total users also there, total users of B is there. Then proportion is nothing but conversion by what is that? Total. Proportion is nothing but conversion by total, and proportion B is nothing but conversion of B by total B. Then Z statistic and P value is what we actually calculate here. And here you can see proportion Z test is also from this library only, stats, right? Like proportion Z test you can take conversion A, conversion B, total A, total B. If you pass, you will get the Z statistic value and P value. Why these two values are important? I just told you that to whether to accept the null hypothesis or reject the hypothesis, we can take the help of P value. Okay. And now understand this problem statement, a real world problem statement. Okay. So this may, like this type of things may arrive in your analytical journey. So here there are two people, Mr. Smith and Miss MRS Miss, right? Like Smith and Russell are there. Two maths teachers are, there's two are maths teachers. They are assigned with 30 students. Smith assigned with 30 students and Russell assigned with 25 students. Okay. At the end of the term one, so both students were asked to take the test, same test. Okay. The average of Smith's students are is 78, and average scored by the students from Russell teacher was 85, and the standard deviations, okay, are 10 and 15 respectively. Then now we are going to determine, we are going to test the hypothesis. These Smith and Russell are equally effective teachers. Okay, so we are going to test the statistical parameters. Here, Smith is having 30 students, Russell is having 25 students. If same students are assigned to these two, then if averages are same, we can easily tell based on the averages of Smith and based on averages of Russell, we can easily determine which teacher is really good, isn't it? Because we are assigning same subject, uh, two different teachers are there, but same subject, same test. But here the number is not same. 30 is what Smith was handled. 25 students is what Russell was handled. Correct. So here in this situation, we wanted to know the which teacher is really performed well, and also averages are also different, 78 and 85. We cannot tell based on these averages, we cannot tell 85 is more than Russell is really good, because here the number is not equal. Okay, correct. So here in this situation, we can take the significance value again 0.05 as a significance value. That means if there is any value less than this, we can reject the null hypothesis. If we can get the greater than 0.05, then we can accept the null hypothesis. Okay. Let us see how can we solve. In order to do this, we can go for T statistic. Okay, comparing the means, right? Average is there, right? Here you can see average means earlier we discussed T statistic, and formulation is like this. Okay, and DF is nothing but their numerator divided by denominator. This is the formulation actually. Already statisticians and mathematicians defined. We have to use the same formulations. Here you can see, just for easy purpose, we are considering one small function. In that function, if I pass two different means and two different standard deviations and two different null I mean numbers, okay, like number of students in group 1, group 2, and then alpha. Okay, alpha is nothing but significance value, that is what 0.05. First, what I'm doing is t statistic. Just simply this formulation, x1 minus x2 divided by square root of s1 square divided by n1 square plus s2 square divided by n2 square. This is what I am implementing. Here you can see. And then numerator is nothing but this one. Denominator is this one. If I club numerator by denominator, that is what df. Okay. After I got these two, then T critical. T critical, this is simply, this is the way. df we have to pass along with that 1 minus alpha by 2. 1 minus alpha by 2. This is the formulation. You have to remember the T critical in T critical and this numerator formula, this denominator formula, and also T statistic formula. And then implement these things. And if there is any T stat value, what is the out of formulation, if it is greater than the T critical value, then we can reject the null hypothesis. Okay, then we can reject the null hypothesis. That means the teacher's effectiveness is significantly different. In case T statistic is less than T critical, then we can fail to reject the null hypothesis. That means no significance difference in effectiveness. That means both teachers are really good. Here the values are mean of students 1 is 78, mean of students 2 is 85. Their standard deviations are like this according to the question. According to the question, numbers are like this. If we pass all those values here, first it will calculate the T statistics based on the question, based on the formulation, and then it will calculate the T critical. Okay, T critical. Then we will check whether T stat is greater than or greater than with the T critical or not. If yes means alternate hypothesis is what true, otherwise null hypothesis is what true. Here you can see fail to reject the null hypothesis. That means null hypothesis is what true, and no significance difference is there in effectiveness. Both teachers are really good, though their averages are different because the numbers are not good. Sorry, not same. So that is the reason we cannot determine based on the numbers. We cannot say that teacher one is good, teacher two is good. This is the way how in colleges and all they determine teachers performance are really good or not. Okay. And then we can go with another concept that is called ANOVA test. Okay, ANOVA is simply analysis of variance. If we extend this name, analysis of variance is what it will give. And why it is important is ANOVA is very important when we wanted to compare the means of three or more groups. Earlier we know T statistic is there. There we are comparing means of two only. Right here also you can see we are comparing means of two. Whenever we are having more than two, then what is the procedure means ANOVA. Okay, analysis of variance. There we are going to analyze based on variance. That is what it is mean. Here you can see the formulation also. Variance between the groups divided by variance within the group. We are considering variance as a parameter to determine or to compare more than two groups. How to do? Let us consider three groups are there. Here again, F statistic is what important, and p value anyway it is everywhere is important. F one way ANOVA, there group 1, group 2, group 3 you can pass. Okay, F statistic you will get as 70, and p value is 0. 0.0. 0.0 means it is less than 0.05. That means we failed to like we have to accept the alternate hypothesis. Okay, our null hypothesis has been rejected and alternate hypothesis has to be accepted. That means there is a significant change between the groups. Okay, if group average is same, then the performance is same means that is what null hypothesis. Performance is not same, that is what alternate hypothesis. Here we got alternate hypothesis is what true. It is less than 0.05, the p value. Got it? So summary, let us consider the summary. If there are two sample mean is nothing but compare, we have to compare, the purpose is comparing the means of two groups. Then we have to use the two sample t statistics in Python, scipy.stats.t test, individual independent. That is the function we have to use. Two sample proportion test. Here we wanted to check the proportions of two groups. That is nothing but in real time. Example is website conversion rate, something like that. Then we can use proportion test. Here we have to use this formulation, proportions z test. Okay, and then A by B testing is comparing two different things. Okay, two different product versions. Email campaigning effectiveness. One of the examples we can consider here. Here we have to use proportions underscore z test again. Then chi-square test is nothing but checks independence of categorical value, gender versus food preference. Okay. Then we can use this chi-square test. Here we can go for scipy.stats again, but here inside scipy.stats we have to use chi-square contingency. Contingency. Then ANOVA is nothing but comparing means of multiple groups. Advertising effectiveness is one of the examples. There we can use ANOVA test, scipy.stats again, but F underscore one way. This is all about the statistical inference part 2. Okay. So now, yesterday I told you how to use Kaggle. So those who missed, please follow now. You can use Kaggle for data sets and for your practice purpose and case studies purpose. And here I can see that there are three main domains are there that been selected by you. One is the credit card and financial thing. Simply, it is financial data analysis. The second thing is healthcare. Third thing is e-commerce. These are the three different domains that I can find some commonality. Fourth one is aviation. Yes, aviation is also there. So four different domains are there. Now, whenever you have some free time, you have to do at least 2 to 3 case studies. Okay. So today is Monday. By Wednesday or by Thursday, so please complete at least 2 to 3 case studies. Whatever the case studies that you worked on, you please answer in the same collab, sorry, answer in the same classroom. You let like fill the next to that. For example, let me open the classroom. In classwork, you can see domain selection, right? Go to that domain selection. So Mushraf is saying finance. So now here, instead of drop down resource, of case study 1, resource of case study 2. Okay. Yeah, there are three links, three different columns I assigned, right? So by at least by Friday, okay, take enough time, don't rush, take enough time, and at least you do case studies of three different things, and you have to stick with EDA only, exploratory data analysis only. Don't go for machine learning. Though I'm going to cover machine learning from tomorrow onwards, but don't uh, observe machine learning part only. Observe till EDA part. How to do this case study job? For example, let me take Mushraf is interested in finance domain. Okay, then go to the Kaggle. Okay, go to the Kaggle. Go to the code section. Go to the code section. Here you can select Python. Okay, so here you can select first of all Python. Then instead of in hotness, you can select first of all most votes. Okay, most votes, and then in search bar, what you can search is finance, right? Finance. Just type finance. Here you can see finance related things. Okay, there are 100 plus results. Most voted only you can choose. Okay, credit card, for example, dealing with imbalanced data set. You just open this one. Okay, you just open this one. You will get this credit card dealing with imbalanced data set. Okay, so understand what is meant by credit card defaulter detector, and before we begin, what is important, our goals, outline, pre-processing, testing, everything is written here. And also understand the NumPy, Pandas, whatever the libraries that I told, only focus on that. Okay, and you will get the data set also using here only input. If you go to the input, there you can see the data sets. Got it? Here you can see data set. If you write, if you click on this one, okay, if you click on this one, here you can see download button, right? Sometimes it is attached here, sometimes it is attached here. You observe. If you click here, you can see a data set being downloaded. The same data set what was used by the this guy. Okay, this is around 6 years ago. Okay, but more votes are there. Consider more votes because that means most of the people liked it. Okay, the way how he analyzed, and use the libraries whatever I discussed, like NumPy, Matplotlib, Pandas, and Seaborn. Okay, these only I used. So use those things only. Is this scikit-learn and all? Let us discuss later. Okay, and observe how he is reading the data set. Of course, we already determined how to read the data set, and what are the functions, and in what way he is doing analysis. Okay, if you click on hidden, try to solve whether you can able to solve this one. Otherwise, you can check the uh, code also. You can see no frauds, how he is able to solving, and in what way he is plotting. Understand the things. Okay. So whatever you understand, don't copy the same code. Same code means, of course, the function may be same, but don't copy. Instead, you try. What you have to do is you can create a Google Colab again. Go to the Colab. Okay. Go to the Colab and click on Open New Notebook. So you can case study one. Okay, you can write it as case study one, and this link you can share it with me. This link if you copy, okay, this link if you copy and can share it with me here. Got it? So this way, you have to complete. You have to complete all three by Friday. Okay. So this particular thing in this particular collab, what you have to fill is what exactly you understood. Okay, what exactly you understood. You write it down. Here, for example, here, uh, this is the one. This you can also read the data set and run the data set. That is fine. Okay, that is fine. If you use the same code, that is fine. But here you write it down. You can use the text, right? You can use the text, you can write it down. What exactly you understood here in your own words. Okay, it is not that you have to use proper English and all. In your own words, you can type here. I understand that this how to check the null values and their count and then max. Okay, maximum null values are attached with which columns. This is what I identified and I learned. This way you have to work on, okay, so that it will help you to come up with approaches. Okay, it will help you to, yeah, to find the best approach. Okay, because here you can see maximum null values are how much. There are zero, there are no null values at all. If there is any ask, I mean, if anybody asks you or any stakeholder asks you which column has maximum null values, instead of we looking at the data set and then counting, directly there is a function available, so that you will get to know many ways. The same data, the same data set, you can see if there is anyone doing on the same data set. Okay. Uh, and here you can see exclusive EDA on modeling XGB plot. You understand different things you can go through, and then different data sets also you can go through. Okay, this is something like a sample submission CSV. Okay, and similarly, it is not required, I guess. It is not the one. Financial concepts and data. Introducing to financial concepts and data. Maybe sometimes the others also teach you the domain also. Here this other is teaching as introduction to financial concepts and data. You can go through and understand the financial, go through that, like trade, how, what is trade, what is market making and making efficiency. So if it is related to your domain, definitely go through, then you will get to know more things. Okay, here you can see what type of functions are really required, what type of analysis is required. Everything you will get to know only from case studies. Though I'm covering the topics, but still you need to go through lot of case studies. Okay, then only you will get to know more detailed part of your domain and a detailed way, a practical application in a what way the real world problems can be solved. Okay, so here you can see whenever time permits. Okay, in your free time, whenever you felt some bore and you want to do something towards your career and towards the practice, better you can go to the Kaggle. Is a very wonderful site for all the data scientists and all whoever interested to learn more. Go to this site and then whatever the way I told according to your domain search, and then most votes you select, so that most people were reviewed this one. That is what. If you like this one, you can also vote. Okay. If you like, you there is one done. There is one option is available. Upvote. Okay. I'm not seeing this one, but there is one option also available. You can also upvote. Here you can see this is the symbol upvote. You can also vote. If you like this, then you can also vote, so that the author will get popular. That's the thing. This is 4 years ago. If you want, really the recent ones, that is also important. You can see more votes and also recent ones, most recent ones. Okay, okay. These are 4 years, 7 years, 6 years. You can also see wherever there are very less. Here there is 2 years stock market analysis. Okay. Let me see another domain. Let me show you another domain. Okay. So healthcare. If you type healthcare, then you can see COVID-19. This is 4 years ago, 6 years ago, 3 years ago, and again all are upvotes, highest upvotes. And 5 years, 4 years, 6 years, 6 years, 3 years. You can find 1 year ago. This is okay. Some recent data. GISR. JSLR, learn EDA baseline. If you want the data set, you can go to the input and you can see here. Sometimes I told, right? You will get the data set from here. Okay. So private data set. Sometimes the others don't want you to download the private data set. Sometimes they're allowed you to download some parts. Here you can see one data set is available, DISLR data set. And then here you can see this is the way they're presenting. What is this? Introduction. What is this? Means this notebook will follow the others learning path and all something. Why it is? Who is this for? All I mean, there are different ways to present our things. Right? And also one YouTube video is also available. Go and check that YouTube video. And if there is anything, and then you can go down, down, down. Oh my God, very well way. Complete things they did, they have given. Maybe it is advanced project. You can see. Okay. So you can observe the code and you can understand what way they have designed this. If it's helpful, then it is really good. Also, you can see the recent ones 4 months ago. This is okay. This is very, very recent one. CMIP IU feature EDA. Okay. Uh, Here they are providing you the domain knowledge also, the dataset overview, and then you can follow how they are solving. Likewise, you can follow the most, I mean, you can take the most recent ones. Okay. If you go to the next search, maybe you will find the recent ones. Okay. If there is any filter like that, that will be helpful, more recent ones and all. No, there is no other filter. We cannot get that based on year, maybe. Yeah. Okay. So similarly, another more thing is aviation. Aviation. Go and search for aviation. Hotel booking prediction, EDF booking and ML to predict cancellations, flight fare prediction. Okay. And also check whether it is very recent or not. You can take the recent ones when out of the available ones. Okay. Whatever makes you feel you the recent one, you can take the recent one. Okay. Here you can see 1 year ago, airline EDA using SQL. Okay. You can try it using Python. Okay. That's okay. Dataset is what important. Okay. Here you can see SQLite 3 is also using. I told you, right, how to connect the SQLite 3 in Pandas starting. This is the way to connect. Okay. You can find how to do analysis. You can also learn the domain out of it. Definitely, why it is important is anyway in your resume, you're going to provide the projects, right? Whatever you have worked on. So the projects means definitely they will test the approach, how you, I mean, how you gone through the approach to solve a problem statement. They will understand your capability out of that uh, approaches. If your approaches are really time saving and cost effective, then really you're a good fit. And you're providing the appropriate and optimal solution to the in the domain, then definitely that will be helpful to them. And finally, e-commerce. These are the four different things. Commerce. Okay. E-commerce segmentation, exploring customer patterns, e-commerce sentiment analysis. Okay, sentiment analysis, NLP. This is NLP. You can understand what is input. But many people may not. Okay, here you cannot get the data set, private data set. This data is private. Then don't disturb that. You can understand this one, Brazilian e-commerce public data set. This is available. Then you can get this. Okay, and you can understand this one, feature engineering and all. And then you can try to get if Brazilian data sets are available, you can get. Otherwise, you can skip this and go to some other data set. This is 4 years ago anyway. Hmm, Product recommendation system. Yeah, this is standard one, product recommendation system. Though it is 6 years ago. So recommendation system, how exactly it is important and what type of analysis can be done. Okay, on textual data especially. You can go through. Likewise, you do reminding people, I mean, reminding domains like healthcare covered, aviation covered, this is covered, this is covered, manufacturing and automobiles. Okay, Maria. Manufacturing, automobiles also, there are lot of automobile data sets are there. Automobile, there are a lot actually, many data sets. You can see there are 9 pages, still one or two, more than one or two. We are getting the one or two in just 9 results only. 9 pages are there. Lot of data sets. Every time they updated. Here you can. This is the field where you can see most updated results. You can see 10 months ago, 1 year ago, 1 year ago, 6 months ago. Okay, and very recent data sets you can find out. Okay, because a lot of things are happening around this automobile manufacturing, supply chain. Okay, okay. So this is the way how you can explore and do the case studies and answer and then share the notebook. You know, let me remove this because you can, yeah, you can fill this, sheet. For example, Gauri Priya and Jnanish both got selected healthcare as their interested area. In this case, maybe you can, like if there are any commonality, try to you can I mean try to discuss you, like what what are the case studies that you are working on. If there are same, then try to solve the other one. Okay. And similarly, here finance is there. Here also financial, retail, and insurance is there. Ranjit and Mushraf. You can, if you want, you can discuss so that at a time you can do six. Three can be solved by one. Three can be solved by two. Person two. So six different case studies can be reviewed at a single point of time. Okay. So you can collaborate if you want. That is up to you. Okay. Now we can take the next topic. Okay. Let me stop sharing my screen. Yeah. If you have any questions, meanwhile, you can ask. I have to get the images to explain the next concept. That is why I stopped the screen sharing. If you have any questions, you please let me know. Where is that file? Please give me 2 more minutes. Quickly, I will find out. Yeah. By the way, is this clear? Like how to do the case studies and all? Is it clear? Can I get any quick response?
Yes, sir.
Yeah. Okay. Cool.
Finding the one casual.
Hmm? Okay. Okay. Let me share my screen. I got that image. Yeah. Is this picture visible to you?
Yes.
Okay. Thank you for the quick response. Okay. So now we are going to learn about the uh, next concept, that is machine learning. Here, let us take this as a reference. Let me show you. Algebra has been covered. Data science life cycle project. This I will cover later. This actually should be, at the top. It's okay. This is nothing but just like defining the problem, how it was. Okay. I have a one picture. I will show you. No problem. Okay. Here we covered the exploratory data analysis. You can see every topic being covered. And then statistics also been covered. Central limit theorem yesterday I covered. Samples, distributions covered. Explanation I covered. CLT means central limit theorem, how exactly we use it in confidence interval and all we covered. Hypothesis testing, null hypothesis, making a decision, critical value. And then Z critical, T critical, yeah, P value, types of errors, normal distribution, T distribution, two sample, A by B, chi-square, ANOVA. All these topics been covered. Now the next topic is about machine learning, supervised and unsupervised. Afterwards, there are lot of topics are there in supervised and unsupervised, then NLP. But like I will explain first deep learning and then NLP. That is the order actually. Okay. And sorry, and then CNN and then NLP. NLP has to come afterwards. These are all Keras and all in between. They will come. Transfer learning is also very good. Transfer learning is also there. RNN is there. RNN is all NLP, building deep learning and all. Then generative AI, then assignments. Okay, good. There are a lot to cover. There are a lot to discuss. So now we, come to this section, machine learning part. Okay. So before going to machine learning part, it is important to understand the overall structure. The same structure will be there in data science also. Don't worry. I will show today itself the data science life cycle also. It is very easy. Okay. So this is what the pipeline we can say. Pipeline we can say, or else the end-to-end process of machine learning and all. If you want to do machine learning, okay. So what is the procedure? First, you need to have historical data, and then we have to perform the feature engineering step. Okay. There is an option, I guess. Where is that? No, edit. Let me show you. Yeah. First, historical data. You will start with historical data. Historical data is nothing but, uh, you know, uh, here the data set, the actual data set. Okay. It can be structured, unstructured, okay, semi-structured. We discussed, right? Structured, semi-structured, unstructured. So you like no matter what the structure it is. So this is all about historical data. That means a data set is given to you to do some operation or to come to build a model. Okay, to do some task. That is what historical data. Already present data, already collected data. For example, last 10 years data. Okay, so based on the last 10 years data, you are going to predict the next year results. So historical means already happened. The second step is, you can see, feature engineering. Okay, feature engineering is what we do. This itself include EDA also. Okay, EDA also is a part of feature engineering. Okay, I can say that. EDA actually helps. Exploratory data analysis is nothing but it will helps us to do or to answer the stakeholder questions and also to understand more and more insights of the data. But feature engineering is something like we do it for, like in order to build a machine learning, what are all the necessary steps has to be performed, the conversions and all, to make a data set ready to go for machine learning. Simply, feature engineering is nothing but we are readying the data set which is about to pass to machine learning. Okay, that is what about feature engineering. After that, if feature engineering data, we are going to divide them into two things: train data and test data, according to the proportion. Usual, the proportion is this is entire data set. Let us consider this is the entire data set. After feature engineering, the same data set will be remodeled. Okay, remodeled means simply like it is going to come up with all the necessary touch-ups and all. Let us consider. Okay, so all the necessary topics which are really important for learning. Okay, this particular data set again divided into two parts. One is for training purpose. You can see here. One is for testing purpose. Okay, training purpose means 80% of the data, let us say, goes to the training. 20% goes to the testing. Okay, so these rates are not fixed. You can consider 70% also for training, 30% also for testing. It is up to you. How do we decide then 70-30 or 80-20? This is actually size of the data set. We can say if the size of the data set is little bit small, we can say 80% goes to training, 20% goes to testing. If it is more than 70-30 is also works. But actually, this rate of conversion is actually dependent on, again, on domain and your stakeholder and so many discussions. Data science job is actually a discussion oriented way. We cannot take straight away decisions. Okay, we have to discuss and we have to confirm it whether this is good or not. Okay, sometimes it is an iterative process also. We check with 80%, 20%, then test the results. If they are satisfactory, okay. If they are not satisfactory, then 70-30, 60-40, 50-50 is not anyway not the optimal one. Either 70-30 or 80-20. Okay, sometimes we even go for 90-10. Okay, yeah. So usually 80-20. Why? Because 80 directly goes to the training. In 20, again, we divide two things. One is for validation, 10%, and 10% we can go for testing. Got it? So let me tell you what all these things. Okay, let me explain you again, once again. I will give you a clear idea with a practical example why this division is required. Okay. Yeah. Why this division is required? Let me tell you. See, let us consider you are learning a mathematics subject or science subject, whatever the subject you are interested. Okay. So let us consider not maths, not science, or something like. Okay, let me ask the audience. So let me ask one thing. Which subject is actually your favorite subject? If I ask you the question, what will be the answer? I mean, what is your favorite subject? Anybody has any favorite subject? Let me know. Rajwal, Maria, Gauri, anybody?
Can you? What's your question?
The question is simple. Do you have any favorite subject? What is your favorite subject?
Subject.
Mathematics for me. That's fine.
Okay. So Ranjit is saying mathematics. Okay, I will. I mean, I need just a small example to consider. That's it. Okay, let us consider mathematics is a subject that you are going to learn. Okay. Mathematics is a subject you are learning. Means in order to learn mathematics subject, first of all, we need a textbook, correct? Or notes, whatever it may be. So we need a textbook first of all. We need a textbook. That is what historical data. Feature engineering is something like preparing a preparing notes based on syllabus. So mathematics subject is always a huge subject, and also textbook is also very long sized one. Or let me consider 300 plus pages or 400 plus pages. But not every single line is required for exam. Syllabus is very short. Syllabus is simply, it is depending on your level. I mean, it will actually it is depending on your level. If you're studying sixth grade mathematics, then sixth grade, what is the capability of a sixth grade student? That is what they will prepare as a syllabus. Seventh grade, they will increase the topics. Eighth grade, ninth grade, graduation level, they will slowly increase the level of syllabus, and they will increase the level of topics. So textbook itself is having all the concepts, but syllabus is what really required to caliber you, or else to test your knowledge or to make you intelligent on that subject. Okay, preparation of the notes according to the syllabus is what feature engineering I can say. That means we don't consider the not required topics for the syllabus, and we only focus on the required topics. In that required topics also, we will again further prepare very short notes, because in textbook you can see the long derivations may be there. Your teachers or professors will help you to come up with short derivations to clear the understanding behind that mathematical concept and all, right? That is what I'm saying. I can say that preparing a notes according to the syllabus out of the textbook is, we can say, feature engineering. Okay, so once you're ready with your notes or content, the syllabus content, uh, if you understand and if you practiced everything, that is what learning, right? In order to prove that you have learned, we have to test your knowledge, correct? We have to test your knowledge. So in order to test your knowledge, what we will do, we will, take some questions, not 100% questions, some around 80% of the questions. Okay, you may learn 80% of the questions, right? So that is what the training data. Training data is something like you have, whatever you have notes with you and the values. And for example, there is a small mathematical function y is equal to mx plus c in your textbook or in your notes, where m is equal to 10 and c is equal to 2 and x is equal to 1. Then this value will be y is equal to 10 times of 1, means 10 plus 2, that is 12. Y is equal to 12 in this case. In your exam, your m value may be 10, but x value may be 6, c value may be 4. In your exam, your values will be different, correct? Your values will be different, but the concept is same. So it is all that to test your skill or to test your capability in implementing the same concept with different problem statements, right? This is what you might have seen in examinations, correct? So the same thing here also. If like here here, learning means this is what we can say final exam. This is what final exam. Before going to the final exam, every school or college, we will have some midterms, mid examinations or quizzes, or else any other assignment, something like that. Why it is important, or why it is required to uh, you know put some examinations or to consider some examinations in a term or in a semester? Because to test the capability. Okay, so let us consider the training data, ML algorithm. These two is nothing but whatever you have learned. Some examination is no happened. Examination examination is considered. So this examination, whatever you are getting, whatever you wrote. For example, 10 questions are there. 10 questions are there in the examination. Out of 10 questions, every question has to be answered. You will be given 10 tens or 100 marks. So you have answered 7 out of 10. And you got 70 marks. Okay, you got 70 marks. So how to test this, like whether you got 70 marks or 100 marks? With the help of test data set. There is always a test data set should be there, right? So to test whether you wrote the correct things or not, okay, to validate your results, they will have an answer sheets, right? So the whoever correcting, they will have obviously answer sheets. They will check with the answer what you have given and with the actual answer. Accordingly, they will evaluate and they will come up with a result. If your result is 70%, but according to the university, if you get more than 80%, then only you will be promoted to the next semester. There is a criteria. If you did not meet this criteria, then what has to be happen? Again, you have to train yourself, right? You have to follow different approach. Okay, you have to follow different approach. First approach is you just prepared examination by following the notes and all. Second time, when there is an improvement is required, second time maybe you consider the previous question papers also. You apply a second strategy, next strategy, which is following different textbooks, different notes. Your data set you will improve. And also you can also consider that Okay, if I learn 5 hours per day, I'm getting 70%. If I learn 6 hours per day, maybe I can get 80%. Got it? Time may be increased, learning can be increased, and also the different approach, like you consider the previous question papers and all, approach is different. Then you again give examination and then check with your results. If your results is 85 now, which is past the criteria 80% and greater than, then only you are ready. Okay, that means you have learned the subject. Then only we can say that you have learned the concept or you have learned the subject, because it is a proof. 85% is what the proof. Okay, then you are ready. If I provide any new data to you, you can answer that particular new data with 85% accuracy. Similarly, y is equal to mx plus c. No matter what the values of m, x, and c, if I provide different values, you can directly you can directly provide me almost accurate 85% accurate results of y. Is this clear? Is this is this explanation is clear? How uh, natural way of learning works and how it is exactly the same process in machine learning pipeline? Is it clear? Is it clear? Is there any confusion?
Yes, yes, yes.
Okay. Maria, it is clear. What about others? Ranjit and all? Is it clear?
It's clear, Ashwin.
Yes,
Great,
clear.
great, great, great. Okay. So this is the same strategy. Got it? This is the same strategy in machine learning also. Now let us only focus on machine learning, natural learning. I mean, no, we anyway discussed about natural learning. Now let us focus on machine learning. What is the way to do machine learning process? If you remember this process in your brain, or else if you always remember this one, then definitely machine learning is really easy and you will know what step to be done here, what is the approach to do and all. Okay, here you observe, you have the okay, you have the historical data set ready. Let us consider you have the historical data set. You have the historical data set ready. That means let us consider one use case also here. Use case is healthcare data set is there. Let us consider healthcare data set is there. Healthcare people or healthcare company is there. They have their data set, collected data set from the patients. Let us consider 500 patients. From 500 patients, they have collected very good data set. The data set involves different columns like age of the patient, and then followed by insulin value, blood pressure value, blah blah blah, some values. Finally, there is one more column is there. That column actually uh, explaining us whether that patient is diabetic or not diabetic. Okay. And this is what the historical data from the 500 patients they actually collected. They really wanted to build one system. Okay. One procedure or one standalone system, I can say, where if they enter values of the patient details, at least the model has to predict, the standalone system has to predict whether this patient is going to affect to a diabetic or not. Why this is required? Based on the result of the model, at least the doctors or pharmaceutical people may have an idea. So to to prepare a diet plan and to suggest recommended drugs. Okay, and also to suggest the exercise plan and related products they can easily sell. Got it? So it's all about business, right? So if this, I mean, if you and if you, I mean, you might have seen a lot of such products in our day-to-day lives, right? In the Google also there are a lot of sites are there. Those sites actually will take the survey from the customer or user. According to the customer details, they will alter the plans. Okay. So for example, if you can see in exercise apps, okay, if you can only exercise 15 minutes a day, and if you can do 3 push-ups, or if you can do 5 push-ups per day, and 15 minutes exercises also, if you have any knee problem or if you don't have any gym equipment with you, then recommended or predicted uh, action plan will be given to you, right? This is also kind of a machine learning. So according to the customer preferences, related things has to be provided. Okay, and consider different factors. If there is only few few questions, then we can go for easy application like one-on-one. If there are only 5 push-ups can be doable from a person, then this is the plan. But in reality, every individual is different, right? So it is up to the individual capability. So that is where machine learning is really helpful here to come up with the most accurate recommendation plans according to the user's needs. So let us consider the historical data is ready with you. Okay, this historical data is always will be messy. Will have all the different columns or rows, different things will be there. Sometimes we can say that all the data points are important. Sometimes some of the data points are not very important. We have to consider some more data uh, to get the most accurate details and all. Let us consider the data set given to you does not have any insulin value, but in reality diabetes is based on insulin values. Then you can also let the stakeholders know that insulin is missing. Then they will consider that and they will include the value and then will given to you. This will actually happens in real time also. That is why it is always important which domain that you really going to work on. If you are working on healthcare, you have to know these things according to the problem statement. You have to research, you have to cross verify multiple times, not only one with one single chat GPT result or any other website. You have to do multiple research things and then only conclude whatever you are concluding. Okay. Okay, historical data set is ready. And then feature engineering is something like I told, right? What are important, what are not important. If there is any missing values are there, you replace it with the most appropriate values. And then, you can check what are the input features required to do this problem. I mean, to solve this problem statement. And what is an output feature, how the output feature is arranged, whether it is balanced or imbalanced. Okay, if it is balanced, then it is okay. If it is imbalanced, what is the step we can perform? All such things are going to happening in feature engineering. Okay, once you do the feature engineering, I told you, right, for learning purpose, we have to divide the feature engineering data set into two parts: training and testing. So training purpose, let us take 80% of the data randomly. Again, I'm mentioning randomly 80% of the data we can pick. This random pick is, again, whether we have to go for randomly or first 80%, it is depending on the domain. For example, if you are working on time series data or stock market data, right? So today's stock price depending on yesterday's. If I go for random rows, if I select, definitely yesterday's one maybe goes to the training data. Today and 3 days before data going to testing, definitely it is not an effective procedure. Their random selection is not working. In stock market data, time series data, simply time series data, random selection is not at all going to work. So then only the selection of first 80% goes to the training, second 80% goes to the testing is what working. Or else customizable data allocation. Customize means you have to manually choose some data points for testing, some data points for training. It is all depending upon your domain. Okay, that is what domain knowledge is very important. Which domain you are really working on. Okay, so this healthcare data set and automobile data set, financial data set, these are all data sets. Okay, randomness is okay. Okay, randomly 80% of your entire historical data goes to the training, 20% randomly goes to the testing. And then machine learning algorithm. Second step you can see machine learning algorithm. Machine learning algorithms means here there are four types of machine learnings. Okay. One is supervised machine learning. Second is unsupervised machine learning. Third is semi-supervised machine learning. Fourth one is reinforcement learning. In this curriculum, we are not going to discuss much into semi-supervised and reinforcement. Okay, we are only going to focus on supervised and unsupervised. Okay, supervised and unsupervised. Okay, tomorrow anyway, I will provide you the content of supervised, unsupervised, and time series data. Little bit discussion about time series data, and also will provide you how to do feature engineering. Okay, all such things I will give you. Today is all about theoretical explanation. What are the concepts actually comes? Okay, in machine learning algorithm, whenever there is a machine learning algorithm, that means according to the problem statement, according to the problem statement and data set, according to the problem statement. Here the problem statement is what? Problem statement is to predict whether the patient is going to get diabetes or not. That is what the problem statement. According to the problem statement and according to the data, you have to choose a machine learning algorithm, whether it is can be supervised or unsupervised. Because in this curriculum, we are only going to discuss these two types, supervised and unsupervised. We have to understand and identify which one is suited according to the problem statement. If you identified, okay, supervisor is suited, then again in supervisor, there are different algorithms will be there. Okay, it will be regression will be there, classification will be there. Anyway, tomorrow I will provide you that information. Regression will be there, if time permits, today itself I will provide. Regression is there, classification is there. You again in regression there are multiple algorithms are there. In classification there are multiple algorithms are. You have to select one. For example, if you identified that this according to the problem statement, classification algorithms are is what really important, then choose one classification algorithm, apply here, and build a machine learning model. Use your test data to validate the results. If you get expected result like 85%, like I told earlier, above 80% is what expectation. If you get above 80% accuracy, then it is okay. If not, means go and select one more classification algorithm. Choose another classification algorithm and try. And then followed, this iteration will be followed till we get the desired. Sometimes what we have to do hyperparameter tuning. What is this hyperparameter tuning? In real time, in real life also, what we do is instead of textbook A, we will also go for textbook B, right? The same subject, but different textbooks are there. We felt that textbook A is not actually meeting the standards of the syllabus, and also marks I'm not getting very well when I'm referring this textbook. Then I will go for a textbook B. Okay, so changing the important values, right? So affected values. That is what hyperparameter tuning. Sometimes hyperparameter tuning can help you to get the most desired value. Okay, hyperparameter tuning and ensembling techniques will be there. Those techniques will help you to get accuracy, good accuracy. Once you get the good accuracy, then it is ready to test with new data, and you will get most accurate results. Whatever the accuracy that you are obtaining, okay, that much accurately the results will be there. And remember that you will never get 100% accurate results. Okay, you will never get, because if you are getting a 100% result, means it is a kind of uh, you know like it is not a dynamic model, it is like a kind of a static model, right? So some 80% and above accuracy is always good. Okay, 80% and above accuracy is always good. Even big companies also not coming with very good accuracy. This is when Netflix was introduced, around 75 percentage of the is what accuracy. There in Netflix, you might have seen the recommendation system, right? The movie or series, whatever you are watching on Netflix, it will recommend you the most suited one or else related one next to the one what you are watching. Correct? That is what recommending. So that accuracy earlier it was 70 or 70 plus. Then slowly they increase their accuracy and by 80 or not. Let me check Netflix recommendation accuracy. Accuracy. Highly accurate 80%. You can see now it is 80%. Okay, so that is why like accuracy, it is very difficult to achieve above 90 or above 100, sorry, above 95 something. Of course, the data set is very well planned. If the data set is very well designed, In that case, you can get above 90 plus 95, 93, 95, something like that. So most of the time we will get challenging data sets where we can give the estimations like above 75 or above 85 is what we can provide the best solution. Okay. So this is all about the story of machine learning. In deep learning, when it comes to the deep learning, instead of machine learning algorithms, if we replace with the deep learning algorithms, that is what the entire process of deep learning. Is it clear? If we just replace the machine learning algorithms with the deep learning algorithms, that is what the pipeline of the deep learning. Similarly, NLP algorithms. Similarly, RNN, CNN. That is what all algorithm only. But the procedure is same. Feature engineering is same. Training, testing, data division is same. Applying the algorithm on training data and testing with the validation results. Test data is only useful for validation, validating the things. Okay. So now we can see the another concept, that is what data science life cycle process. Life cycle. Okay. Yeah, this is good. Okay. So this is what the data science life cycle. This data science life cycle, if you want to do end-to-end data science project, then what is the life cycle or what is the procedure? Step one is, it is very important to determine or understand the business, the problem statement. But it is very important to understand the problem statement clearly. If you get the problem statement clearly, then we can go and work on data understanding. Let me take 1 minute to charge my system. Yes, it is starting now. Okay. First step is always business understanding. What is the exact business that you are working on, or what is the problem statement that you are working on? Earlier, I told you, right, one business statement. That is what, let us consider the healthcare industry. Okay, they wanted to know the diabetes or not according to the patient's data. Okay, that is what the business. Okay, and according to the business understanding or according to the data set, we have to understand what data is really required. Okay, what data is really required. Okay, so understand the data and then prepare the data sets. So get the data, required data, and then do the exploratory data analysis. This is what we performed using NumPy, Pandas, Matplotlib, Seaborn. We are analyzing, right? We are analyzing all the things. Okay, this is what exploratory data analysis. After doing exploratory data analysis, we have to work on data modeling and data model evaluation. Data modeling and model evaluation. These two steps is nothing but machine learning. This process. Come back to this process. So historical data. This is what the historical data, data preparation, data understanding. Okay, and then come back to here. So feature engineering is something like I told, right? EDA also involved inside of feature engineering itself. Okay, and then after EDA, some more steps has to be performed. That is what feature engineering. Anyway, tomorrow I will show you. Okay, with the Python codes and all. Then you will understand the difference between EDA and feature engineering. After doing the feature engineering, then model building, model. This is all model data modeling, and then model evaluation. This is what here. Once you confirmed that your results are very good, then you can go and deploy the model. For example, the customer, I mean, the business people are willing to have a website. Okay. Inside the website, they really want, a feature. That if anybody click the feature, then inside the feature, then they can enter the data. And once they enter the data, then recommendation has to become. I mean, recommendations or doctor appointments, automation has to be done. So that is what deployment. You can deploy accordingly, and once you deploy the things, you can write the code and you can define the applications and you can do many more things. Here you need the skill of MLOps. Okay, model deployment. If you are willing to work on model deployment, then MLOps, DLOps, DevOps related thing, and software development like Flask or C. You can use any one of the frameworks or REST APIs and all to develop an application, desktop application or mobile application. Okay, it is all comes under model deployment. Okay, so till before model deployment, till here is machine learning or deep learning, NLP, LLMs, whatever it may be. It is what learning. Okay, and implementation of that learning process to into the reality. Up to here is all about business understanding and all. Whatever I mean, the I mean, once you deploy the model will answer definitely that will answer the questions or it will design according to the business only. That is why it is again touched to the business. It has to follow according to the business. Okay, is this point clear? That is what it is all given here. Data science lifecycle project. Define the business problem, understand the raw data, prepare the data, modeling the data, evaluation and deployment. Is that clear? How exactly data science project is going to work?
Yes. Yes.
Clear? Yeah, thanks, Maria. I hope it is clear to all of you. Okay. Yeah, thanks, Prajwal. Yeah, okay, Ranjit. Okay. That is why, here if you can see in Kaggle also, uh, let me take Kaggle. In Kaggle also, whatever the data set or whatever the things that we are working on, it is clearly doing the same thing. Here you can see. First, let me take a very good Kaggle one. Yeah, let me take this one. Automobile. Let me take one thing and we'll show you. Car manufacturing, car information, automobile. Okay, car information. If you see any project inside Kaggle, they follow the same. First, they do they consider one data set. They read that. This is what EDA starts exploring the data. Okay, exploring the data and then cleaning the data. Okay, they remove some unwanted things. Feature engineering. This is all again feature engineering. So doing some modifications and analyzing the data, visualizing the data. Okay, and understand more and more insights of the data. Once they get all the information out of the data sets, then they will go for machine learning. You can see going down. There lot of analysis is required. And by the way, let me tell you time, time taken by every concept. If you are working on in a data science project, okay, if you are a part of a data science project, then most of the time will be spending on EDA because data analysis is not a simple thing. We have to answer many questions. We have to understand the problem statement or business thing very clearly, in depth. Then only we can build a better solution for their business, right? That is why exploratory data analysis is what will take a lot of time when compared to remaining steps. And model deployment also will take time. This machine learning part will not take much time if you do data analysis properly, if you make the data ready and very clean and uh, right way, then it will not take much time. Out of the practice only, you will identify the right algorithm, right things, and all. Out of the practice only, you will get not straight away 1 day or 2 days. You will not get and can tell me like this can be the algorithm I can use something like that. Out of the practice only, it will come. Okay, so this will also take time, but not that much. This is actually depending upon the data engineers of your team and data gathering people and maintenance of the data on clouds server side. So whoever working on that one team, it is all a team project, not an individual project. One team will work on this. One team will work on this. One team will work on this and this. Collectively, these are all considered as one data science life cycle or data science project. Okay. So earlier I worked on data modeling. Okay, I worked more into data modeling. I did not get. I also got some opportunity, what opportunity to work on data preparation. Okay, data preparation according to my modeling. That is why I prepared. Okay, so my manager gave me like, okay, you can only do because team is working on other things. You can do. I tried doing data preparation inside GCP using BigQuery and all data preparation. EDA, another team did. According to the EDA results, our my manager or my delivery manager suggesting me, suggesting our team, okay, which data model you can use, or you which machine learning model you can use. You can try that machine learning model. Then model evaluation also I worked on, okay, a bit, so that whatever model I am building, I have to explain the results that for example, I am using a model X, and this is the result of model X. Model Y, this is the result. Then my stakeholder will decide whether to go for model X or model Y. Okay, or my not my stakeholder, my manager and delivery manager will decide, because those are the senior people, and also those are the domain experts. Especially they are domain experts in the team. Every team will have one domain expert. Okay, one mathematician means who can do exploratory data analysis and all very well. One person will be working on SQL, cloud, Snowflake, whatever it may be, the data management and data engineer. Okay, and one team will work on machine learning, and one team is always will be there to do on ML ops. Okay, collectively it is called as data science project. Got it? In the same way, you can see any data like here. Data analysis is what it is doing here. Like this, other is doing a lot. Finally, once the data analysis is done, once he get the things is required for the problem statement, once he understood, okay, what is going on, then only goes for machine learning. Here, maybe if there is any prediction, object recognition, CNN, price regression, okay, maybe in this Kaggle file, you can see, oops, these people are restricted. No, not restricted. I would like to show you pre-processing. These are all pre-processing, and then says modeling. You can see data modeling. Okay, so selecting the best features, applying machine learning. This is all machine learning, and this is what data, I mean model evaluation. Okay, once they evaluate the results, see here you can see this is the same way. This is the same way. Let me save in the bookmarks, because this is the same way. Okay, how in real time we used to do. Okay, linear regression, inside linear regression, these are the models, different models, and these are the scores. Which score is really good? Here it is saying like this score is really good, and this score is even really good. Okay, then it is better to go for this score. Okay, this is the way. And then again we'll try with real time statistics and all. Okay, and then we'll finally conclude which is really good, and the good one we will go and take that and then implement and build an app using that particular model. Got it? This is what evaluation, model evaluations. This is what model building or data modeling. Okay. Earlier, this is what data modeling. This was done after EDA, if you observe, after EDA and feature engineering. This is what an end, this is not end to end because model deployment is missing. Model deployment is missing. Up to here, it is good. This project is there. Up to here, model evaluation, whatever I just marked, that project is having up to model evaluation. Model build deployment, it is not actually in the course, but anyway, I will, if time permits, I will show you a simple example of model deployment, not with using MLOps and all, because cloud access we don't have, right? So I will show you with a simple local host machine. I mean, local host application, simple Flask, using Flask or using Streamlit, I will show you. In LLMs anyway, I will show you, don't worry. Model deployment also, I will show you. Okay. So this is all about data science life cycle, and completely we covered till here. Okay. So completely till machine learning, above machine learning, and machine learning pipeline we just covered. Tomorrow I will start with what is supervised, what is unsupervised. and supervised learning. Linear regression, I will start linear regression also. If time permits, linear regression and all these concepts. Then logistic regression, all these concepts, nav base. Then one day, two algorithms we are going to cover. In that way, we will cover all things in time. Then unsupervised learning, 2 days for unsupervised learning. These concepts anyway will come in between only. Then deep learning. In deep learning also, what all these concepts are, how to do deep learning, okay, regularization. These are all topics will be covered in 1 week. Computer vision, basic video analysis, how to do these all things. Okay, pooling, max pooling. Okay, very good concepts are there. Good, fine. This is all about today's lecture. Today you learned about statistical inference remaining topics, and also you learned the data science life cycle and machine learning pipeline. Okay. So tomorrow I will continue. I will continue. First of all, I will explain the machine learning, the types and how to identify the type. And then I will show you feature engineering part, which is whatever the feature engineering part that I'm going to explain you tomorrow. Remember this concept, this point. Whatever the feature engineering that I'm going to cover tomorrow, that feature engineering is not same to every machine learning algorithm, because it is always depends on your domain. Okay, according to the domain, we have to do feature engineering. But tomorrow I'm going to cover with the help of either automobile data set and any other data set. That data set, that is what the approach, that is what the way how to do feature engineering. Okay, if data sets are changing, feature engineering steps also going to get changed. Okay, and machine learning algorithms also going to get changed. Some anyway, tomorrow I will give you real time examples and all. Okay, yeah, Prajwal.